Hey, hi everybody, welcome back to Stats with Aaheli. It's been a while since I have uploaded. I know it's been way too long, but I'm back and honestly this comeback feels very special because it's a starting of my second year and uploading videos and content related to that. And thank you so much to everybody who stuck around and kept messaging me to upload again. This one's for you, okay? Now, as you can see, there is something interesting and very new which I am showing here in my screen. This is the interface of R Studio. So you can understand from here that what I'm trying to say. This is the episode 1 of starting a new playlist that is learning our language for statistics. Okay, now if you are for here for the first time, or you're someone who's always wanted to learn it but didn't know where to begin, this playlist is going to walk you through the step by step the way I am learning it myself in my own coursework. Okay, and today in episode 1, we are starting right at the foundation, that is data types in R. Before we can do anything cool, that is with vectors, functions, loops, stats models, we need to understand what types of data R actually works with. Okay, so let's get into it. But first, let me show you a little bit of things. Like if you do not know how to install R, see, first you need to go to CRAN and download R, okay, and then RStudio. And if you want a full dedicated tutorial for that, please comment that down. Then I will make a video on that. Okay. Now see, and one thing more, that is I have I'm using here Mac. Okay, so the interface and the commands will be a little bit of different rather than Windows. Okay, so I'll be sharing with you how to use it in Windows also. And look at here, the font here is a little bit bigger than the standard. Okay, now if you want to know how do I change the font in Mac, then look at here. First, I don't know if you can see this. See, here is a tools option. You need to go to the tools and then go to, see, global options. Once you go to the global options, then you will see option here, appearance. Now look at here. Here you have got the option of editor font size. Then you can change your font size according to what you want. All right, now as I have already done it, let's skip that portion. And something more which I want to share is that, see, before learning our language, you must be familiar with the previous semester topics, right? That is of the determinants of the matrices. Okay, that is for the, please follow the linear algebra playlist, because here in this course we are going to do numerical analysis in R. Okay, so first for that we need to learn R and then we will go to numerical analysis. Now see, the first thing here we need to understand in R is that R is, what is R? What is R called? R is called a dynamically typed language. Now, what does this mean? What is this dynamically typed language? That basically means you do not have to sit there and explicitly declare, hey, R, this variable is going to be a number, or this one is going to be a text. You do not have to do that. You just assign a value and R quietly figures out the type for you in the background. All right. But here is the important part. Even though you do not have to declare it, every single object in R is still assigned a specific data type internally. All right. R is doing that classification whether you see it or not, and that classification decides what you're allowed to do with that object later. Like, can you do math on it? Can you compare it? Can you glue it together with the text? Like, what can you do with that? So let's go through these common data types one by one. First, look at here. See, I have written everything here in hashtags. Now see, what is this hashtag command do? Hashtag does not show you in the console part. This is the R script part, this is the console part. If I am doing, see, look at here, if I am pressing clicking the cursor here and then pressing command plus return for Mac, and for Windows it will be control plus R. Okay, anyway, coming to this, see, when I am doing that command plus return, then do you see this hashtags part in the console? You do not, right? You are getting directly to the part where the code is written. So let me show you another thing, that is when you are trying to write anything which you do not want to show in your console part, actually in the code part, you just add a hashtag there, then it becomes a comment. Okay, so it does not show in the console part. Now see here, this is the first data type which we are going to learn. This is the logical one. Okay, now look at the comments here which I have written. It represents a truth value used for conditions and filtering. So the first data type we are talking about is logical. Now you can think of this as R's way of sorting or storing a simple yes or no, true or false answer. Okay, it's what shows up whenever you're checking a condition or filtering the data. As you can see here, it has only two possible values, true and false, and R even gives you shortcuts for them, that is capital T and capital F. But here you see the quick note, that is these have to be in capital letters. If you write small letter true, that is the lowercase true, then what happens, that R will get confused and throw an error. Okay, now let's see it in code, and I'll make a logical vector. Check if it is if its class is, the code is dot logical. Okay, and we can confirm confirm that if it is doing what we expect. Now look at here, see, as I have given this, x is here a variable name, and this is an assignment operator, or you can just simply write equal to here, because we have not got much as advanced here. Anyway, let's use the assignment operator. X assignment operator C. Why are we using the C here? C is here used to get the values together. Okay, like if there was only one element here, then we need not have to write the C, but here there are multiple elements, so we have to write the C. Okay, now see, x assignment operator C, true, false and false. Now I am calling x again with the command plus return. Okay, now see, when I'm calling x, what is happening, the values are getting printed. The values, what are the values, true, false and false? You can see that the values true, false and false got printed. Now I need to check that if it is logical. Now for that, what is the code, that is dot logical, and then what is the variable name, you need to write that. Okay, let me see. Now see, when I am doing that is dot logical, then it checks that if x is logical or not. And it is logical, right? Because true, false and false falls under what? Logical data type, then it is coming to be true. All right. So this was all about the first data type which we learned. Now next up is integer. This one's for whole numbers, no decimals. Okay, now here's a small quirk that literally trips up a lot of beginners. Why? Because if you just type a whole number like 5, R does not automatically treat it as an integer. To force R to store something as an integer, you need to add a capital L right after the number. So, like 5L becomes that integer. That L is the signal that says treat this as an integer to the R. Okay, and how do we check it? We will check it as same way, is dot integer, then we will write a variable name. Now look at here, what do we have? See, when I am writing this is x to be the variable name, and I am assigning x to be 5L, and then I am calling x. When I'm calling x, what is happening? 5 is coming because that is the integer, right? Now see, what if I want to check that if x is of integer type or not, then what happens? We will use the code is dot integer. Okay, now look at here, it is an integer, so it will come to be true. So this was all about our next integer part. Now we have numeric. And this is actually the default type R gives to any number you type in. For example, if I have not written that L here, then it would treat that as numeric. Okay, whether it has decimal or not, it does not have any kind of condition whether it has decimal or not. Okay, unless you specifically force it to be an integer with that L. So numeric is the flexible one. It can represent both whole numbers and decimal numbers. This is the type you will be using constantly once we get into actual statistics work, okay? And we check this with again the same type of command, that is dot numeric, and we write the variable name. All right. Now let us come to the part. See, here I am writing 5.2 because I want to show you for the decimal number. Okay. See, I am assigning x to be 5.2. Then I am doing what? I'm calling x. It is coming to 5.2. Now I want to check if x is numeric or not. Then let us see that. Now we can see that any value is numeric. That is the default data type of R for numbers. Okay. So it is coming to be true. Now, coming to the fourth type. The fourth type is character. This is how R stores text or string data. All right. Anything you want R to treat as words rather than numbers needs to be wrapped in quotation marks. This is what you would use for names, labels, categories, anything textual. Okay. Even if you write a number inside quotes, like in quotation, if you write 5, R will treat it as text, not a number. And that distinction matters a lot, as we will see in a second. Let us see. See, here I have written my name. Name is here a variable, and I'm assigning Aaheli in the name part. Okay. Now, if I'm calling name, what happens? The output will come. Output is coming in quotation marks, as you can see. So this means wherever you see the output in quotation marks or in quotation marks, that will be a character. Okay. So let us see that if it is a character. Now see here, our variable name has changed to be name, right? Not x. So we will write name here. Is dot character, in brackets we will write name. That is true because that is a character, right? Now if I have to show you something else, like as I said, if I would say this, now 5 is a number but it is in quotation marks. Now we will see that if this works as well, if this is a character as well. See here, name here is 5. I'm calling name, then name is coming to be in quotation marks 5. Now I want to know if this is a character. This is again a character. Why? Because the number 5 is here in quotation marks. Okay. Now look at here. This part is very interesting and something which I love to learn the most. Okay. Data or system data. This is like bonus reference for you. Now, if you want full month names, then you write this code month.name. Then you want to see what happens? I'm calling this and see what happens. All the names of the months are written in order, okay, and in character type because these are characters, right? Now, if I want the abbreviated month names, then the code is month.abb. Okay, let me call it. Now, see here, the abbreviated month names have come. Now, see, it's the same way goes for the small upper. This is the lowercase letters. Now what will get printed? Lowercase letters from A to Z. Let us see if it works, and it works. Okay. And for uppercase letters from A to Z, look at this. All the letters from A to Z is working, is coming in as the output, and this is coming in uppercase. Now this one, this particular thing, Sys.time and in bracket, this is very important and kind of something which you will need for your assignments, because your professor is going to ask you for the system time and date while you are uploading the assignment. Okay. So sys.time and in bracket, this will give you the current system date and time. Now I don't know if you can see here, this is 2nd August 8:12 a.m. Let me see. It is coming to be the same. Now see here, you can see the system date, you can see the system time. Now if you have wrong system date and time, then obviously you will get that only. Okay, so whatever there is in your system, what time is in your system, what date is in your system, that will come here. All right. Okay, now coming, this was something very fun which I love to learn. And now coming to this one. Now this is again very, very important. This is like type conversion. as.family function. Now, what is this as.family function? Now, this is where it gets genuinely useful. What if you have data in one type, but you actually need it in another? That's where this r's as.family of function comes in, like as.numeric, as.character, as.logical, as.integer. These will on these we will work. Okay, so the key thing to remember here is that, and this confused me at first too, is also that just running a conversion function does not change your original variable. It just returns a converted version. If you want the change to actually stick, you need to assign it to a new variable or override the old one, anything. Okay, but I would suggest that it would look very clean, and you will also be getting help from that. That is, when you are assigning a new variable to that converted one and then you call it, then you can see that that variable has changed, the type of the variable has changed. Now, see, we will of course walk through a few examples. See, what are the examples we are going to work with here is that converting a logical vector into numeric and seeing how true becomes 1 and false becomes 0. We are going to do that. Okay, converting numbers into logical where 0 becomes false, and any non-zero number, positive or negative, becomes true. Okay, and for converting text like true and false into actual logical values, and what happens then when the text is not recognizable, then let me give you a spoiler, it will be na. Okay, and trying to convert something like a name, for example my name Aaheli, into a number, and seeing r basically throws its hands up and gives us a name, because that conversion just does not make sense. How can you turn a name to a number, right? So let us see that all the things which I have just discussed now. See, I have written here everything, type conversion. Now this is like very important. Conversion functions do not change the original object. They only return a converted copy. Must assign it to see the change. Okay. Now let me see what happens. See, I'm calling this x. Now, see, what is this x here? X is a variable name. This is the assigning operator, and I am taking the values, the elements to be 1, 2, and 3. Now, I want to check if this is numeric or not. Okay. Now, see, then what is the code for to check if it is numeric or not? That is dot numeric. See, when I'm doing that is.numeric x, then I'm getting to be true because these are numeric values. Now, if I want to change this to be a character, these values, these 1, 2, 3 to be character, then what do? We take the code to be as.character and give the variable name. Now, this is just a preview. X itself is unchanged. Okay. Look at here. As.character here, how do we know that if it is character or not? We need to have the quotation marks, and here you have the quotation marks. That means it has got changed to a character. But now if you just write here, not this part, wait. Okay, now if I want to know that if it has changed to character or not, then what do we need to write? Is.character x. Now let me run it. That is false. But why did that just happen? Because we have already turned it to be a character, but when I'm asking that if it is a character, then it is saying to be false, because this thing, conversion functions do not change the original object. What is the original object? Object is 1, 2, and 3. That is, it is the numeric type. It is not character. Now what happens is that if I assign a new operator, a new variable, y as a new variable, assigning to as.character, this one, I am assigning this one to y. Then what happened? Now the change is actually saved. See, I have first assigned the value. Now I am calling it y to be 1, 2, and 3. Now if I see that if it is numeric, then what happens? It is coming to be false because it has got changed to character. Why? See here, I have also written false now since y is a character. Now here if I have written is.numeric x, then it would have been a character. Okay, it would be a true value. Now look at here. Now next conversion is character to numeric. Now see, only works if text looks like valid numbers. Look at here. First I am seeing z. Z here is what? A variable name, and I am assigning the operator, I'm assigning the values 1, 2, 3, 4, and all are in quotation marks. So this, what does this happen? These are in character, right? Now as dot numeric z means what? We are changing these values from character to numeric. Let us see. It happens, it works fine, converts cleanly. How do we know that it has got changed to numeric? We have seen that the quotation marks are missing here, so it means that it has got changed to numeric, right? Now look at here. So okay, before coming to na, first let us see what we were going to discuss. See, I am again taking another variable x, and then I'm assigning these values 1, 2, -3, 0, 5, and -7. Now, if I want to change it to be as.logical, I want to change this numeric values to logical values, then what happens? See, 0 stands for false, and non-zero, any number, positive or negative, it will stand for true. Okay, so let us see if it works. See, first I am doing what? I am calling this, I'm just running the code of x, and now I want to change it to be logical. See what happens. 1 is a non-zero number, right? So it will be true. 2 is again true, -3 true, but 0 stands for false. So you can see here it is false here. And then 5 and -7, it is non-zero number, so it will be true. Okay. Now see, if I want to change the logical operators, logical data type to numeric data type, then what does happen? I'm saying a variable name y, and then I'm taking few logical operators, that is true, false, true, true, and false. Now I want to change these logical operators to numeric operators. Then what happens? See, for true it will become 1, and for false it will become 0. Okay, let us see if it works. See, for y I have just called the y, and I am now changing it to be numeric. Now, why is it 1 here? Because it is true, false for 0, true again 1, true 1, and then false again 0. Okay, now look at here. What I was talking about, that NA1, that if there is something which is not recognizable, then what happens? Now here I'm trying again for character to logical, but this only works for exact true or false spellings. Okay, now see, I'm taking another variable m. Okay, and I am taking the values true, false, true, and Aaheli. Now look at here. If I'm trying to change these logical operators to logical only, because I want to know if this works, because we have not learned this capital and small letters true, right? We have not learned that. We have only learned that it will be working only with capital letters, and Aaheli is there. But is Aaheli will be a logical thing? Let us see. I have first run the code of m, and then I'm trying to make it logical. Here true is again getting converted to the capital true, as it is the default type in R. So my suggestion will be that when you are writing any logical commands like true and false, please do write in capital letter, like uppercase letter, for true and false. Like avoid the capital letter T and F, the short forms. Okay, please do write true and false like this, then it will be helpful for you. Okay, and even for R also. Anyway, coming here, why is NA coming here in for Aaheli? Because Aaheli is not recognizable, right? Just a moment. Now, yes, when I'm talking about NA, like speaking of NA, let's talk about it properly. Just a moment, let me come here. Look at here. What is this NA? NA is basically the missing value type. NA stands for not available, and it's R's dedicated way of representing a missing value. It's not zero, it's not blank text. It's a specific placeholder that says there's supposed to be a value in there, but we don't have it yet. Okay, so you will see NA show up naturally wherever a conversion fails, and later on you will see it show up constantly in real data sets too. So it's good to get comfortable with it early. Okay, as you can already see that here, while I was trying to convert this Aaheli to a logical operator, then it was coming to be NA. As I said, that it shows up automatically when a conversion fails. Now coming to the next type. Okay, so we did not discuss about this numeric to integer conversion. Let's do that. See, here I have got the numeric elements, right? Numeric values. That is, here we have the decimal points even. But for integer, do we have the decimal points? We have only the whole numbers, right? So when I'm saying a variable x and we are assigning the values to be 1, 2, 3.71 and 5.90, and I want to convert it to be integer, then what is the code? That is as.integer and the variable name, that is x here. Now here what happens when we are trying to convert the numeric to integer? If there are decimal values, as we have the two values, then the decimals will get omitted. Okay, let us see what happens if that really happens. See, I have called the x, I have run the code, and now I am trying to change numeric to integer. Okay, now what happens? Here, as you can see, 3.71, it is not getting rounded off. It is not getting just 4. It is omitting the decimal values, the values after the decimal point. Okay, so it is just coming to be 3, it is just coming to be 5. Okay, now look at here, x1, I am now assigning a new variable name x1 for this integer thing. X1 is now as dot integer x. Now if I call, if I want to see that if it has already changed to be integer, then let us see what happens. Now I have already assigned this to be a new variable name. Now it will not show me the original data type. It will show me the data type of this one because this is a new variable. Let us see. It is true because now it has turned to be integer, right? So now see, x2. Now I am taking another variable x2 and I am taking the values 1L, 9L, 7L. Now look at here, for x2, these are the integer values, right? Now I want to change it to be numeric x2, numeric of the variable name x2, right? Now this is not, if you just this is not the correct way to do it. You have already, I have shown you so many examples on how to do it. Now by this time you have already understood that here it will be as dot numeric, right? So let us do that. Let us see if it actually works when I'm calling x2 and now I want to change to numeric. Okay, this is an error. Why? Because this is not the right function. You have to be very careful. Now what happens is that if you want to change this to be numeric, then what happens? You need to add as. Now run it to be. Now see, here you can see that these integer values, that it is coming the output to be 1, 9 and 7. Now look at here, for x3, now I'm assigning a variable name to this as.numeric x2. Now when I'm assigning a new variable name, this, then what happens? Then it changes its data type to numeric. Let us see. It has changed to numeric. As you can see, the output to be true. Now coming to this portion. Now, this is basically the last thing for today. How do we actually check what type something is once we have made it? Like R gives us three functions for this and they are not identical. Okay, so let's break down the difference. As you can see, class. Class here gives you the high level classification of an object, the one that governs how it behaves statistically and computationally. This is usually the one you will use the most. Okay, next coming up is the type of. Type of goes one level deeper, telling you how the low level internal type of how the object is actually stored in R's memory. This is important. Please, these are the key points. Okay, see, this is stored in R's memory. It actually stores, it actually gives you the output how it is stored in R's memory, and this is what it governs statistical and computational behavior of the object. And next come is the mode. Mode gives you the basic storage mode of the object, like whether it's numeric, if it is character or logical. It's simpler and less detailed compared to type of. Okay, so you can think of it like this, that mode gives you the broad category, class tells you how R treats it in practice, and type of tells you exactly how it's sitting in memory under the hood. Okay, now So that is basically all. See, here I am taking to be x3. What was x3 here? X3 is this one, is dot numeric. Okay. So here it is giving the output for these class, type of, mode. Okay, the what is the class is numeric. What is the type of? It is double. It is how it is stored in R. Okay, and mode is what? Numeric. It is the basic storage mode, numeric, character, or logical. Now that is basically all for today's class. Today's episode 1 of the Learning R playlist. We have covered the core data types logical, integer, numeric, character, and NA, plus how to convert between them and how to check what type you're working with few bonuses like how do you get the month names, the letters, and the system date and time. We have also learned that. In the next episode, I'm going to start with like rules on how to give you a variable name, how to make a variable name. Okay, like here I was taking only characters, right? X and what name I have taken, x y z m l. I was taking few letters as the variable names, right? And in the next episode I'm going to discuss on the rules on how to give a variable name. So that is all for today's class. If this helped you, hit the like button, subscribe if you're new, and drop a comment if there's a topic you want to learn for R. And yes, that is all. Thank you for watching. See you in the next one. And if you have any kind of doubt here, please write down in the comments, and you're also free to message me in the Insta. So see you in the next video. Bye bye, take care, and practice as much as you can.